Assalamu alaikum everyone. A very good evening. So we will be starting our session now. Uh, Hello, ma'am. So our first session of day 2 is data analytics and its future scope, and our speaker is Dr. Soma Pratibha, Associate Professor, Department of Information Technology, Sri Sai Ram Engineering College, Chennai, India, Vice Chair, IEEE MAS section. Ma'am, the floor is yours now.
Am I audible?
Yes,
Yes, ma'am, you're audible.
Okay, thank you. A very good evening to one and all. And first of all, I thank the organizers of this international conference for organizing such a big event with so many technical talks going on. For I think 2 days event it is.
Yes, ma'am.
Yeah, so it's really a very good work. Congratulations to all the organizers, and thank you for providing me the opportunity to share a few knowledge about that today's topic. Okay, let me, and also uh, I should thank all the participants for taking their valuable time to listen to the lecture. Okay, hopefully it will benefit to you. So let me share my screen.
Ma'am, you are muted.
You are able to.
Yes, ma'am.
Yeah. So I hope my screen is visible to everyone.
Yes, ma'am.
Yeah. So first of all, from the participant side, anybody already knows about this one, this topic, which is today's topic. I'm going to talk about data analytics and its future scope. So data analytics term, it's not right now we cannot say it is a new one. It's been like almost in the mature stage since from last 5 to 6 years. Lot of things happening in this domain, and it has been one of the technology that is essential for almost all the organizations to run properly. So in the participant side, let me know whether many of you are familiar with this topic, or is it a new one? Like you have a little bit knowledge on this, so that like where exactly we have to go in detail, like that we can come to know. No? That's right. Few of you, if you can share your knowledge level on this topic. can give in the chat
Assalamu
box.
alaikum. Assalamu alaikum.
Yeah, assalamualaikum.
Walaikum assalam. Ma'am, my name is Taiba Khan and I have some knowledge about data analytics.
Okay, very good. Okay, you are in which, you are studying what?
Ma'am, basically, I am from Pakistan and currently I am studying Bachelor's in Software Engineering from Riphah International University, Islamabad.
Very good, very good. So you have a little bit knowledge on data analytics,
Yes,
correct?
ma'am. Yes. Ma'am,
Okay.
basically, everything,
Mm.
raw fact and figures that we use in our daily life is data. And data
Yes,
play a very important role in our life because without data, we can't be communicate with one another.
very good, very good.
And when we organize data in row or column forms or in manageable form, that provides the good source of information for communication from one people to another is called data analytics. And it is very useful in our future.
Okay, there is a small corrections, whatever you have said. Data analytics is useful only, but it is not that always you expect your data in terms of rows and columns. Okay, so that's where exactly analytics, data analytics differs from database. Okay, so we are going to see about it. We'll see about it. Very good. Thank you for taking the initiative and speaking out.
Thank you so much, ma'am.
Yeah, very good. Yeah, so I understand that few of you might be having a little bit knowledge on this one. So now I have organized my lecture within this half an hour span. What we'll see is that data analytics deals with what kind of data, okay? What exactly we are going to achieve through analytics? What kind of companies use this analytics? Okay, and then with respect to future, data analytics has a lot of scope, and also there are demand for this job. Okay, data analytics, people with the knowledge of data analytics and people who knows the tools on this domain for the next 5 years, according to Gartner, is going to be a lot of scope, and on an average, they will be earning more than a normal like more than a software developer. It is also estimated like that. So that's how this topic has a like you can get more benefit when attend on these kind of seminars or guest lectures to improve the knowledge level on this topic. So some of the facts which makes what in data analytics, you see the major word is data. And we know that in this century, a very important thing is data. It is like a weapon, data, isn't it? So one of the important fact is that it is doubling every 2 years. And one of the estimate says that in 2023, by the end of 2023, we have around 1.145 trillion megabytes of data being generated on this earth every day. And what is the reason why so much of data? We all know that right now everybody is connected to a device and everybody is able to generate the data. Okay, so every one of us are always on the almost all we are in a day of 24 hours. We are almost on the internet for 16 to 18 hours, and then we are doing lot of activities on this internet, and then we are generating lot of data. Every human being is generating lot of data. Okay, so that's how the generation of data is tremendous. And it is that these are some of the interesting facts that I have taken. Like one person is generating around 49.8 GB of IP traffic every month. And in that one, we all know that right now everything on internet, we do a lot of videos we'll be watching. Okay, so video traffic also makes up to 82%. And then the major IT giants like your Google, Amazon, Microsoft, Facebook, they also store a lot of data, contributing a lot of data. Okay, and one more important thing is that out of this, whatever data we have, The original data is almost only 15%, and the remaining is almost like repetitive. Okay. And there's one more important fact. By 2023, it is assumed that every human being, okay, like there will be 3 times as many connected devices as people on Earth. Okay, so devices will be more than the human beings. So that's what is the situation going to be. Okay, so that means that you have a voluminous amount of data. Okay, and we all already know that just a data is not going to be of anything of use. Whatever the data that is generated, it has to be analyzed, it has to be processed, then only you will get meaningful information. Correct? So for that only we are talking here about this one. This is okay, like this graph, you also can see that how much tremendous of data is getting generated now. Like initially you can see in 2006 where we are, and right now, like the last 3 years back, how much data is getting generated. 40 zettabytes of data. And where we were like 14 years back, it was just a 0.16. Okay, so a lot of factors are there which influences the growth of this data. Like 2006-7, affordability of devices was not that much. We didn't had that much internet connectivity. Okay, so those things made us not to have, like every human being was not contributing to the data. Whereas right now the situation is different, correct? So that's the reason why this domain of data analytics has emerged. Yeah. So now we talked about how much data is existing, correct? Now the data that is existing, we can classify into 3 types. One of the participants spoke very nicely about that one. She said that like data will be in terms of rows and columns, and that kind of data, if it is available in terms of rows and column like this, then we call it as a structured data. And most of the database applications in earlier 2010 and all, like at that time, most of the applications were have to deal with the data which is stored in this format. Okay, rows and columns. But right now that is not the scenario, no? Like when I'm using the Instagram, if I'm posting something, like if I'm posting some information, and if it is mandatory that I have to post the data in this format, rows and columns, obviously nobody is going to use the Instagram. Nowadays, the applications are so flexible that they allow you to post any kind of data, correct? So that kind of data, we call it as unstructured data. Okay, so unstructured data is basically, there is no need that you have to divide your data into rows and columns like that. So whenever you are posting your videos, images, audio, all those things, in which you are not bothered about the type or like how you are organizing your data, then we call it as an unstructured data. Okay, and in between these two, we have what is called as semi-structured data. Okay, wherein there is some flexibility is there, but still it is not so free that you can do, you can post any kind of things there, or you can store your data in any format. For example, your XML applications, your spreadsheets, email, those kind of things, basically we call it as semi-structured data. So whatever the data we were talking in the previous slides, the type large amount of data we were telling, no? So that data is it may be of any of these 3 types. Okay. And what exactly our research says is that among whatever the data that is available, we have basically large amount of unstructured and semi-structured, and very few amount will be on structured data. That is, you cannot make any compulsion to your customers that you want your data to be in this format only. Okay. Now, so after seeing what is data, what are the facts about data, and we have seen what is the different types of analytics. Now, we have what exactly this field of data analytics to do with. Okay, so it is basically among whatever data you have to examine it and analyze the raw data sets and what you are going to get from this. From that, you are going to derive a meaningful information and you are going to conclude something from that data. Okay, and because of that, after applying data analytics, you will be able to what the organizations expect is that there should be an improvement in their business, product sales, and providing the services to the customers. So data analytics basically helps the organizations to analyze their data and improve their business. Okay, that is, if some company is interested to start a new branch, then they have to study that location. So when they are studying that location, they'll be having a large amount of data about that location. What kind, how many, what is the population, what is the demography of that population, and what is their interest. So much data is available about that location. Now, this analytics program will identify that data set and will provide you with what exactly this company is interested to. Okay. So apart from organizations, data analytics is also used by data scientists to verify their scientific models and theories. And as I was telling, I think I can skip this one. It helps the organization for better decision making, also for cost reduction, quicker decision making, because everything they are able to get whatever the things they are interested, they are able to identify, and even better visual representation also will be there. So thereby they will be able to do the decision making can be improved. And there will be one more word which almost seems like the same, data science. Okay, so there is a little bit difference actually, but the domain is like analyzing you are dealing with a huge amount of data. So in the data science, the scientists are basically interested in verifying their models. Okay, upon the whatever the data that they are dealing with. Okay, whereas in analytics, basically you are like identifying interest in what kind of goals you can achieve and where exactly this particular decision can be applicable. So those things, we are not verifying the scientific models in analytics. And if we are interested for starting a data analytics project, basically we have to identify the goals of the project. As usual in software engineering, whatever you have, the same thing. To identify the problem, define goals, identify the measurable goals, then from where the data is getting generated, list the sources and collect the data, and then you have to you have to use analytics softwares to analyze. Now, after analyzing, you cannot get whatever the numeric values you get, that will not be of any useful things, because pictures speak more than text. So you need to do a visualization, and through that one afterwards you'll be performing the decision making. Okay, so the same thing. We'll move on to the next topic is basically different types of data analytics. So over the period of time, after the usage of data, emergence of this data analytics, we basically classify the analytics based on what kind of thing you are doing. Okay, what kind of conclusions, what kind of knowledge you are getting. Okay, and this graph, you can see that we have, it shows that you have 4 types of analytics, correct? So this 4 type of analytics, in the x-axis, I have complexity, and in the y-axis, we have added value of contribution. And this says that, so in descriptive analytics, complexity is less, and also the value contribution after doing this analytics is less. Okay, whereas the prescriptive analytics is complex analytics, and after completing this prescriptive analytics, you'll be able to gain a high value contribution. You are able to gain lot of information about that data. Okay, so that's how this graph has to be interpreted. You have 4 types of analytics. So quickly, the first one, which was descriptive analytics, is very simple. What we do here is that whatever the organization has, its historical data, just we'll go through that historical data and you'll just do summarizing. Like you use some aggregate functions and you are able to come up with some facts about your data. So, for example, here, let us assume that the company has some 4 kinds of products, A, B, C, D. Okay, and this descriptive analytics is done by identifying, like by by examining the product sales. They are able to get some aggregated values, like A has got this much, B has got this much, C is this one. So from this analytics, instead of raw data, it is difficult to identify, no? But from this analytics, you can see that the highest sales was for product C and then the lowest sale was for product A. So this kind of information only you'll be able to obtain from descriptive analytics. Now we have a next level of analytics, which is called as diagnostic analytics. So in the previous case, see what happened is you just say which was high, which was low, but you didn't examine why the A was not able to have that much product sales. Okay, what factors were there which contributed that A had a less number of sales? Okay, so that also has to be done. So that kind of analytics, next level of information you can get by doing diagnostic analytics, will drill down your data and find out why exactly the factors affected in making that whatever the values we have got a particular attributes. Next, the last 2 were basically about already whatever has happened, you are examining that. But organizations are interested to find out something, like if they are launching, if they are planning to launch a product, before launching itself, they want to predict what will be their outcome of this product launch. They are interested nowadays. They are interested for that one. Okay, so that kind of analytics is predictive analytics. Not only product, what kind of decisions organization is taking. For every decision, if they want to know, if I take this decision, okay, what kind of outcome I'll have. Okay, so that analytics you can do by carrying out predictive analytics, wherein we talk about what can happen in future. And here comes AI. Okay, so you will be doing machine learning part and train your model with the various data, and then you will be able to generate some predictions about that data. Okay, so that's little bit complicated, no? Because you are not working on only historical data here. Next is prescriptive analytics. So prescriptive analytics is similar to how doctors prescribe as a prescription when you visit your doctors when you are not feeling well, no? So similarly here, in the prescriptive analytics, what actions we have to take, how to optimize, all those things you'll be doing. Okay, like if something happens, right, what kind of remedies can be done, what kind of recommendations can be used. Okay, so this again uses advanced ML, decision analysis, and game theory. Lot of technologies comes into picture of this one. So this is quickly about different types of analytics, and predictive and prescriptive analytics are obviously the most interesting and most sort of things wherein you have to gain your knowledge. And these are some tools that are basically used, data analytics tools that you should be familiar with, like R language. A whole Python language has a lot of data and data analytics library is there in that one. So you can use that one. Even a simple Excel also can be used for performing the very basic descriptive analytics you can do with the Microsoft Excel also. Tableau is there, Rapid Miner 9. Power BI is somewhere now, right now, a very mostly used right now by organizations. Microsoft Power BI, Apache Spark, and then ClickView, Talnet, Splunk. So lot of analytics tools are there. So it is like you have to master any of these things like Tableau, Python, okay, Power BI. These are some of the things which are most of the organizations are already started using, and people are looking for, organizations are looking for the people with this knowledge in these kind of domains, in these tools. I would like to wind up my session with the future scope of data analytics. Data analytics has a very bright future. Okay, as we know that the generation of data, availability of data, the organization's dependency on data is going to be there. Okay, so there are certain things through which the technologies which will be integrated with this one, and they have to have a major role. So one of that is obviously AI. We have seen in the previous two slides that you have two important analytics like prescription analytics and predictive analytics, wherein you have to work with your ML and deep learning models. Okay, so AI powered analytics can help basically business. A lot of automations can be done, correct? So it help a business to better do the decisions. Next is we know that lot of connected devices are there now. Okay, so IoT, Internet of Things. Okay, so it also is contributing to the voluminous amount of data that is getting generated, and whatever that data that is generated through IoT, you can do conclusions, you can derive something from those one only through data analytics, correct? So that's how IoT and data analytics has a lot of scope. Next, the Gartner has coined one important term for predictive and prescriptive analytics, and they basically call it as X analytics. Okay, here X analytics, X stands for any variable, and Gartner conceptualizes. Gartner is like they are the people who basically that organization predicts what kind of technologies are there, what kind of technologies will be in hype in a particular period of time. Okay, when it will reach to a mature level. So those things are basically conceptualized by Gartner. Okay, so here X basically stands for, it can be a structured or unstructured, and it can also refer to video analytics, audio analytics, or text analytics. That is, analytics can become a generalized thing, wherein we call it as a X analytics. And of course, data analytics has a lot of scope with cyber security analytics. Apart from that, there is a one more analytics that people are telling that analytics will be of a lot of interesting things to come in that one, which is called as augmented analytics. Okay, so it is basically like you have two things here. One is augmentation and another one is NLP. So basically, this domain deals with automation using AI, and then whatever the things you have to be communicated with the people, you will be communicating to the people through NLP, so that even non-technical people can understand what exactly the things required. Instead of giving the output in terms of a visualization, they may give it through commands also. So that's one more interesting area where this is a future scope. Okay, so a lot of things are there to talk in data analytics. So within the given time, I just wanted to talk to you about a brief on data analytics, where exactly it is used, and then types, and then what kind of scope you have. Being a student, you'll be having, you can work on these kind of domains in your projects and can contribute a lot in this area. And once again, thank you very much. Hopefully, the lecture was useful to you. Thank you.
Thank you so much, ma'am, for this wonderful talks. I believe students have learned many new things about data analytics, and it will help them to pursue career in data analytics. And thank you, ma'am. And
thank you. Thank you.
Ma'am, there are a question from audience from chat box, like which tool is best for data analysis, from Abdul Rauf.
Yeah, so as of now, most sought tools are like we have Python also has a lot of things. So Python, apart from that, Power BI and Tableau. These three are mostly used. R language is also there, but when it comes for industry side, we have seen application of Python, Power BI, and Tableau.
thank you, ma'am. Now we will be moving forward with our next speaker, Dr. M.D. Kafil Islam, Senior Member, IEEE, Associate Professor of Department of Tripoli, Independent University, Bangladesh. His talk will be use of machine learning and deep learning in biomedical signal classification and their application to health. Sir, the floor is yours.
Hello, good evening from Bangladesh. I hope that I'm audible and you can see my slides.
Yes,
can you confirm?
Yes, sir, we can see your slides.
Okay. So let me start then. So I thank the conference organizer or congress organizer, Congress and Trends in Computer Science, to allow me to be one of the speakers of this event. So I am Dr. Mahmoud Kafil Islam from Independent University, Bangladesh. I'm also the branch counselor of IEEE student branch. And we have a small research group called Biomedical Instrumentation and Signal Processing, which is headed by myself. So the title of this talk is use of machine learning or deep learning in biomedical signal classification and their applications in healthcare. So moving forward, this is my short bio. So I have done my BSc in Electrical and Electronic Engineering from Islamic University of Technology, Dhaka, Gazipur. And then I have my PhD from National University of Singapore. Currently, I am working as an associate professor in the Department of Electrical and Electronic Engineering, Independent University, Bangladesh. So this is my lab, introduction of the biomedical instrumentation signal processing lab. So these are the topics that we work in our research group, especially biomedical signal processing and classification. Biomedical signal refers to, signals like EEG, ECG, EMG, EOG, EPG, etc. We also work on biomedical instrumentation and assisted devices, and all the applications of this instrumentation, signal processing and classification algorithm in healthcare and medical diagnosis. For example, in brain-computer interfacing application, in understanding or diagnosing or detection of any disease, in basic neuroscience research, in human-machine interaction, in rehabilitation of any disease, neural prosthetics, and so on. We also, the signals, biomedical signals, they have also some non-clinical applications such as neuromarketing, biometrics, or entertainment, like in a smart TV. This particular talk will be focusing mainly on the application in healthcare and medical diagnosis. So let us talk about the background of biomedical signal. So the way the biomedical signals are referred is the type of the signal, whether it is an electrical signal, a mechanical signal, or a sound wave, or it is an magnetic signal. And then the name of the organ from which the signal is recorded. For example, if the signal is recorded from heart to understand the activity of heart, then we call it cardio. If the signal is recorded from brain, then we call it encepha. So encepha is a Latin name for brain. If the signal is recording from muscle, then we call it myo. And then the type of the presentation, gram, graphy, or graph. So graph, you obviously know that what is a graph. Graphy is the technique of acquiring the signal. Gram, again, is nothing but picture or image of the signal. So ECG, I hope that you are still with me, just confirming that.
Yes, sir.
Okay. So for example, if you take an example of ECG or electrical activity of heart, so ECG means electrocardiography or gram, electrocardiogram. So this is how the name are actually mentioned. So in our lab, we actually mostly we process electrical activity of different organs, which means we talk about ECG, ENG, EOG, something like that, not magnetic or mechanical. But there can be different types of origins and different types of signal as well. So what is the motivation of acquiring or processing and or classifying these biomedical signals? So the main motivation in healthcare or medical diagnosis is that you have a patient, you acquired the biomedical signals, you process the signal, and you make some decision based on the signal, right? So what is the state of the patient? What is the diagnosis? What is, if the treatment is going on okay or not, whether the patient is in coma or not. So there are different types of decision that you can make. And these decisions will eventually be made through application of some kind of machine learning or deep learning algorithms, okay? So starting from biosignal acquisition to, amplifying the signal and doing some pre-processing and removing some noise, which are often known as artifact as far as the biosignal are concerned. And then you extract some features and you do the classification to make some decision. So these are some of the applications that often these kind of signals are acquired, processed, and decisions are made based on the classification, based on the pattern recognition of the signal, recognizing the signal type. So in patient monitoring, in critical care, and for disease diagnosis, for example, understanding if there is any problem with the heart through ECG, to understand if there is any neurological disorder or disease through the help of EEG, to understand if the muscle signal working properly or not, we use EMG. Sometimes we record the signals for future prediction. For example, these days wearable devices allow us to record biomedical signals on the go in a continuous manner, which help eventually in prediction of any, for example, heart attack prediction can be done through the continuous monitoring of your ECG and pulse rate. In human machine interfacing, for example, brain-computer interface or brain-machine interface, people suffering from different disabilities or physical challenges, they can use this signal as a control signal to control electric wheelchair, prosthetic arm, or computer. These signals are eventually used for treatment and rehabilitation, and also to understand the basic physiology and function of different organs. These signals are often recorded, processed, and decisions are making. So what is the basic challenges of biomedical signals? It is the fact that if you take a look at this graph, the amplitude of the signal and the frequency of the signal is given. So ECG, EMG, EEG, that's just for an example, 3 different types of biomedical signals are plotted here. But you take a look at the noise over here, the noise has higher amplitude than the ECG, EMG, and EEG. And out of these 3 signals, biomedical signal, EEG has the lowest amplitude in few tenths of microvolt to hundreds of microvolt, which means that EEG signal has a very, or in typical biomedical signal has a very low signal to noise ratio. And biomedical signals are often non-stationary and non-linear, which means that if you have a signal which is non-stationary, that means with the time, the signal properties changes, the statistical property, the frequency component of the signal, that changes over time. So it's very difficult to actually process and understand this signal because they are very complicated signal, and also the SNR, the signal to noise ratio, the quality of the signal is very bad. And therefore often, and these noise are often known as artifact. And sometimes these artifacts, they overlap with the signal in both time and frequency domain, which means traditional digital filtering will not work to, if you want to remove those noise on artifact. And these noise eventually what they do, they mislead the diagnosis, they mislead the decision making, or mislead the control of an external devices. Therefore, these are some of the challenges that are unlike to other signals. So let us talk about one application of EEG, electroencephalogram based brain-computer interface. So this is a non-invasive technique of recording brain signal by placing electrodes on the scalp, and then you do the processing, you extract the features, do the classification, and eventually through your brain signal, you will be able to control some external computerized device. For example, electric wheelchair, prosthetic arm, robotic arm, or you can control your computer as well. So this is an example where this person is actually, by imagining, he is controlling some cursor or he's actually playing some games on computer without using the traditional input devices such as keyboard or mouse. So BCI will be helpful if your traditional link between your central nervous system and peripheral nervous system is broken due to some injury or accident, or any disease, neurological disease. So that time you'll be able to control any external devices through your imagination or through your brain signal. So this is a very important application where you can see that classification. That means you need machine learning and deep learning algorithm. So let us talk about just a brief on EEG signal. So EEG, as mentioned, that it is an electroencephalography, which means that it is an electrical activity of brain signal recorded on top of the scalp. So it is a non-invasive recording technique. And EEG is preferred over other brain imaging or brain signal recording techniques because it is low cost, non-invasive, easy to use, and it has significant amount of temporal resolution. Now, let us talk about artifact a bit. So artifacts are kind of noise in your EEG signal or brain signal. So artifacts, they often make mistake in interpretation of the neural information or the brain signal. There are different types of artifact. There are different sources of artifacts, starting from environmental sources, experimental sources, or physiological sources. So I'll not go into detail, just to understand, to give you an idea that what happens if there is so many artifacts. That means eventually your classification result will be affected, and your classification performance will be negatively affected. Your performance accuracy of the classifier will be reduced. So that is the point that I wanted to mention through this slide. So let us talk about AI, machine learning, and deep learning. So you all know that AI, these days, it has been so significant that you already are familiar with ChatGPT and all these stuff. So I just want to make you understand that it started back in 1950s, actually, the concept of AI. And now we are somewhere in 2020 and 2023, between 2020 and 23. And in this time, our deep learning, even machine learning has been very traditional, and deep learning has been the new way of, application of machine learning or AI in different applications. So machine learning and deep learning both are actually used in biomedical signal classification and decision making. So we understand that deep learning is an advanced form of the machine learning where deep neural network is used. So moving on, how this machine learning and deep learning are used in brain-computer interface classification. So there are supervised classification like SVM, ANN, artificial neural network, or deep convolution neural network, which is known as deep learning, basically. So if you use deep learning, then your pre-processing it will not be required. Feature extraction will not be required inherently. They can use the feature extraction technique. And then there are unsupervised classification or clustering, known as like K-means clustering. So what happens is that you record this brain signal through quite a number of electrodes, and this is a very big data. And eventually, you apply some machine learning or deep learning technique after some pre-processing or feature extraction to understand what is the person is actually imagining in brain-computer interface, or in disease diagnosis, or in understanding of any event or detection of any particular event that will be helpful for diagnosis or detection of any disease. That can also be done through this model by applying some classification technique from the subject. So there are different types of brain-computer interface technique. For example, invasive BCI, non-invasive BCI. So whether the recording is done through, outside of your scalp, or your scalp is opened, and then inserting some kind of electrodes on the brain, inside the brain to understand. So this is an invasive BCI. And then based on EEG signal type, there can be spontaneous or epoch potential. And then they're based on mode of operation, there can be synchronous or asynchronous brain-computer interface application. So I'm not going to go in detail, but just telling you that there are different types of BCI, brain-computer interface system, where these machine learning and deep learning will be eventually used. For example, motor imagery, MIBCI, or SSVP, like steady-state visual evoke potential BCI. So just ignoring the technical detail at the moment, let us start with some sample project. Okay. So this is so I'm going to actually give you all these examples of where in our group we have used machine learning and deep learning on different biomedical signals to make some decision. And these are some of the real project that we'll be talking about. So the first is the effect of artifact removal on EEG-based motor imagery BCI. So you understand already that I talked about artifact, which is nothing but a noise on EEG signal, in brain signal. And there are different types of BCI. One of them is motor imagery BCI. The motor imagery BCI, basically the person imagines some kind of movement, but without doing that actual movement. So for example, you can imagine the left hand movement or the right hand movement, right? Without doing that actual movement. And that can be actually extracted and classified through machine learning from that brain signal. Okay. So what happens where we have tried to understand what happens if we have a signal that is contaminated with artifact like this one. These are the spikes that are the artifact. And after we remove artifact, the signal will look like this. So with that signal, we have tried classification. With this signal, we also applied SVM, support vector machine classification. And what we found that with the increment of the signal to noise ratio, because we have removed the noise, so obviously the signal quality has been improved. We have found that the classification accuracy has been improved by on average 15% of classification accuracy can be improved if we remove artifact from the biomedical signal, because artifacts are nothing but noise. So obviously, when you remove noise, you enhance the signal quality, and therefore the classifier has a better performance in that regard. So moving on to the second project, where we have found that where you have used a deep learning or deep convolutional neural network known as CNN to understand EEG signal classification for application in SSVP. So this is another type of BCI, which is known as steady-state visual epoch potential based BCI. And we found that we tried actually different types of CNN model, and then we achieved this kind of accuracy. So I don't want to go again into technical detail, but what I'm trying to say that in different BCI we are actually, or in different application, we have to use this classification technique. In this case, we have used deep learning. In the previous section, what we said that we have used in machine learning, traditional machine learning, that is the SVM. So let us move on to the third project. So again, this is another project based on EEG signal. So what we have done, we have tried to predict the depression among young adults. This was sponsored by IUB in our campus. So young adults means aged from 18 to 25, the university students. So we have tried to find out, whether the subject has depression or no depression with the help of EEG recording. And before that whether this, because that your machine learning or deep learning, you need label data, right? You need label data to train your model. So to train your model, you need some validated reference data. And that reference data, whether the subject, they have depression or not, that is done through the traditional screening tool, for example, PHQ-9. So this is how traditionally the psychiatrists, they evaluate any patient, whether the patient has depression or what is the level of depression, or it is a healthy subject, okay? So we have used that as a ground truth data, and then from the EEG signal, we have actually tried to predict what we have done, what we have found from the screening tool, okay? So we have used two traditional machine learning algorithm. One is SVM, another is KNN. And we have tried to find out whether the subject is healthy or depressed, okay? And we also find out that the brain map, they are different from the healthy subject compared to the depressed subject. So we found that we can actually predict the depression or understand depression through EEG analysis with an accuracy of more than 96%. So this is an example. So another example is again using EEG electroencephalography, or brain signal, but this time for different application to understand, to detect epileptic seizure. So epileptic seizure detection is very important for patients with whether the patient has an epilepsy or not. So epilepsy is a neurological disease which, if the seizure happens, the brain actually produce some uncontrolled neural activities which actually make some uncontrolled movement of the subject. So this is very harmful because when the seizure occurs, thousands of neurons, they get damaged because of the seizure activity, okay? So not every time the seizure occurs, the seizure also. So it is very important. It is one of the most is very basic problem in people with neuroscience or neurological disorder that are dealing with, that to understand and to detect epileptic seizure in a more accurate way. So what we have done here, we have tried to again apply artifact removal algorithm on the EEG signal and extracted feature, and then try to classify whether it is seizure or normal. Okay. So we wanted to find out whether the artifact reduction actually enhances the epileptic seizure detection performance or not. So again, you understand that we have used some kind of classification technique. And because the feature extraction is there, that means we have used some machine learning, traditional machine learning, not deep learning. So just to understand that, here we have extracted few features. For example, entropy, kurtosis. So these are different statistical features, okay? And the red one are actually the seizure activity, and the no seizure activity are the blue one. So what we have found that the features after artifact removal, the features can be easily distinguished, okay? For example, you can see here, after artifact removal, the features for seizure and non-seizure, they can be easily differentiated. But before artifact removal, they were very difficult to differentiate, which means that after artifact removal, your classification ability should be higher. So we have seen that we have, before artifact removal, the number of false positive that we had, and after artifact removal, the number of false positive, they have reduced significantly. We found that improvement in false positive artifact, is around 50%. So this is an example where the red ones are the artifactual EEG and the blue ones are the non-artifactual EEG, and then we try to remove those red ones, those artifacts, and then we try to find out what happens after artifact removal. So again, as per hypothesis, we found that the seizure detection or seizure classification ability of our machine learning classifier has been greatly improved after reduction of artifact. Moving on to the next. So this is another example of using a single channel EEG recording. We said that we can actually from related with mental health. So what the subjects were actually, they were shown different types of movie clip like horror and relaxing, and we have tried to estimate those whether the subject was watching a horror or relaxed movie from the EEG signal. So again, we have applied different types of classifier, and then in this case, the example table is for an KNN, K nearest neighbor classifier, and we found like 80 to 90% classification performance or accuracy. Again, this is an example where automatic artifact detection and removal has been done from EEG signals using intelligent fuzzy system or fuzzy logic. So again, another example of machine learning. This one is not an example of EEG signal, but it is an example of EOG, which is known as electrooculography. So electrooculography is actually when you move your eyeball, there are some deflections. Whether you are moving your eyeball horizontally or vertically, we can actually detect those. So electrooculography is actually your eye movement activity. So through electrooculography, we have actually, in our lab, we have developed this signal acquisition, EOG signal acquisition device. And what we have to do eventually through eye movement and eye blink, we want to control some external computerized or electrical appliances. For example, electrical wheelchair, or to control the cursor of a computer, or control the prosthetic arm. So you can see that here there are because your eyeball can move in 4 different directions, like left eye movement, right eye movement, up and down, and then eye blink. Okay, so we have tried to apply a machine learning, or eventually this project requires machine learning application to classify these 4 or 5 classes, right, of your eye movement. Moving on to the next one. So this is an interesting one. Here we have not used typical, biomedical signal. Rather, we have used our smartphone accelerometer to understand whether a person has fallen or not. Okay, so it is a human fall detection, and this will be helpful because aged people with 65 years and more, they have a very frequent falling experience. So, the motivation of the project was, if you can detect that fall earlier, then you can send some support system. So what we have done, we have used the smartphone accelerometer to actually record these acceleration for different fall and non-fall events, and then we apply some machine learning algorithm, and then we have to classify whether it was a fall event or a non-fall event. So again, another application of machine learning in detection of fall for immediate medical help for the aged person. This is another example where we have used a smartphone camera to actually collect the images of your skin in order to find out whether that skin has some disease or it is a just normal skin. Okay. So again, application of deep learning. So use deep learning. We have also developed some MATLAB-based tool so that we can actually just collect that image and then we'll be classifying with an accuracy whether it is an affected, disease affected skin or a normal skin. Moving on, finally, in conclusion, what we should say is that when you are recording biomedical signals, we have a lot of challenges, especially in ambulatory recording. There will be a lot of motion artifact due to the movement of the subject, because in real-time processing is required often in applications like brain-computer interface application. It requires, real-time processing. So that means it is involved with computational complexity. So what kind of signal processing and machine learning or deep learning algorithms you are going to use, they have to be real-time, suitable for real-time processing. The cost is also an issue when you are talking about a portable device on any application. It's always about the trade-off between the accuracy of your deep learning or machine learning model and the complexity, cost, and feasibility of the system. The robustness, how robust it is, your deep learning model, whether it can be reliable or not. So these are some of the challenges. So future possibilities are endless because there are a lot of advancement in the recording technology, recording of acquisition of biomedical signals. A lot of new advanced signal processing techniques are there, and also the deep learning and machine learning, the AI tool, they have been upgrading day by day as well. So it creates a lot of opportunities to work on this field, for biomedical signal application, biomedical signal classification. So with that, I would like to end my talk here. Thank you very much. I'd be happy to take any question if you have.
Thank you so much, sir, for this wonderful session. Also, thank you for sharing in-depth knowledge with the students in use of machine learning and deep learning in biomedical signal classification and their application in healthcare. I believe your talk will help our students very much. And I would also like to congratulate you for being winning the Outstanding Student Branch Counselor Honorable Mention. Congratulations, sir.
Thank you. Thank you, all the organizers, for having me. Thank you.
Now I would like to call our another speaker, Dr. Rajesh Kumar Tiwari, Principal, RBS College of Engineering and Technology, Academic Advisor, IIUC Technologies Private Limited, and National Cyber Safety and Security Standards, New Delhi, Advisor, Jharkhand University of Technology. His talk will be on Industry 4.0 and Education 4.0. The floor is yours now.
Hello? No, sir, it's a bit fuzzy, sir, not clear enough.
Audible?
Yes, sir, we can hear you now, sir.
Actually, I have already talked with your Tabil, and due to some unavoidable reasons, I am not able to have with my laptop. And the place where I am, the network is not good. So it is not feasible for me to have any slides with me. Only I can share some of my experience, some of my message to you all. First of all, it is a great thing that you are arranging this type of international congress on recent trends in computer science and technology and applications. It is really good. And regarding my topic, what I can say, Industry 4.0 and Education 4.0, in a very brief, in a short, what I can say, Industry 1.0, that is the first industrial revolution. It is meant for Great Britain, England, you can say. The main the invention was the James Watt, and the entire things were changed due to first industrial revolution. Second industrial revolution took place in Europe, and entire Europe changed. James Ford, the owner of the Ford car, was the main person, the main people behind the second industrial revolution. Similarly, the third industrial revolutions came for nuclear power and all, and the major affected area was the America, and the fourth industrial revolution is going on. And all my dear students and all my dear friends, see if we can do something on this industrial 4.0 revolution, that will help these Asian countries. We are not as similar to the European and all. They are already very much developed, and they are enriched with many new technologies. And due to that, what is found personally, there is a huge gap between some of the leading countries of Europe and other part of rest, this Asia, and even some part of Africa and all. So this fourth industrial revolution can change a lot in our life. Major things for changing of this industrial 4.0, just before my speech, I heard one of the session which was going on, although it was not the complete session, I heard it. But these artificial intelligence, machine learning, data science, cloud computing, and recently this augmented reality and virtual reality, these all areas are very, very important for us. And as a researcher and a scholar, what we can do, how much we can contribute in this area, that will decide that how much we can do for our country or for our society. These all applications, these all areas are very important for all the country, and for the development. These all things are very important. If we talk about the education, of course, education 1.0 is simple education, teachers and students. Second, education 2.0, it was chalk, board and chalk, using chalk with explaining where it is, if we compare with those type of concept, it is client server, we can say, like a teacher is a server and all the students were the client. Now education third and education 3.0 and education 4.0, it is changing a huge, and which is going to help for the industry 4.0. There is a word of intelligence. It is now adopting in education also. Intelligence in the sense, simply invention is not enough. Now invention with intelligence is important. How much your system is intelligent, that is very important. And it is true in our education system also. So in these way, we can contribute for industry 4.0 and education 4.0. As I don't have any slide and I don't have the literature also, I cannot explain a lot of things on that, even though I had prepared a lot. But I'm really sorry for, due to some unavoidable reasons, I'm not able to continue on it. But again, a very thanks to all the people who are behind this international Congress and their effort. Thank you very much.
Thank you so much, sir, for taking some time from your busy schedule. Though you are have another, I think you are not prepared for this, but though you have come and share your knowledge with us, we are very thankful to you for that. And thank you very much, sir. Now
thank you so much. Thank you so much. The place where I am, the network is not good. So extremely sorry. And next time, I hope that I will be able to contribute in your this international congress. Thank you so much again. All the best for your entire team. Thank you. Thank you. Bye.
Thank you so much. Now, moving forward, I would like to introduce Dr. Muhammad Shamsul Arifin sir, Senior Member IEEE, Chair IEEE Computer Society Bangladesh Chapter, Professor, Department of CSC, Daffodil International University, to say a few words of appreciation. Sir, the floor is yours now.
Thank you very much. Thank you all. At first, I want to thank all the speakers. Actually, this event is today's event, and we have different student branch chapters as well as student branches actually collaboratively going to organize this event. And it's our pleasure to see many great speakers, keynote speaker, IEEE President-elect, and many other speakers from home and abroad to join in this today's event. So we have several keynote speeches today, and even it is finished by Dr. Rajesh Kumar. Actually, we are highly grateful to you and other keynote speakers for being with us. Actually, IEEE Bangladesh section, IEEE Computer Society Bangladesh chapter, as well as its student branches and student branch chapters, always trying to do something that will help our researchers, our professionals, our students to develop themselves in the right way. So the man who is behind this great event is Tabil Ahmed. We can mention that he is the man behind the machine. My sincere congratulations, gratitude to you and your team for this, for such type of fantastic event. And we hope in coming days we shall continue these type of events. IEEE Computer Society is always ready to provide all sort of supports for the professional development of our, that means researchers, students, as well as professionals. So I think we all collaboratively can develop that means knowledgeable society. We are from developing countries. When we are sharing knowledge, we get to get knowledge from our developed countries. Speakers from these countries actually help us a lot to enhance ourselves. So IEEE and IEEE its chapters in global arena actually contributing a lot for professional developments from our Bangladesh. We are also trying to do that. And ICRCS actually is an initiative in this regard. So thank you very much. Thank all the speakers. And one thing I want to say, you will be highly happy to see that probably if I am not in a mistake, there are more than 15,000 actually registration for these events. And we had some Zoom limitation. We were broadcasting it in our YouTube channels, and actually we have also good number of participants actually lively joined in our that means Zoom. So I am also grateful to you all, the participants. Actually, most of them are students from different universities. Actually, the future is yours, and we want to do something for you. I hope you will also be with us, and it will be great. And as a whole, I am actually very, very happy to see that this event, I have to say, actually, although it is the support from IEEE PDC, but our student branch chapters, they worked a lot to make it successful. And I can feel proud for their great effort and the success of this event. And we want to continue this event in upcoming days. So thank you very much. Thank you all. It's our great pleasure. Hope you will enjoy your upcoming days. Thank you.
Thank you so much, sir, for appreciations. Now I would like to request all the participants to turn on their camera, and we will be taking some photos or screenshots. Okay, on count 3, I will be taking photos. Ready? 1, 2, 3. Okay, photos has been taken. Thank you, everyone. Now you can turn off your camera.
Thank you so much.
Dear participants, attendance sheet has been given in the Zoom chat box. Please kindly fill up the attendance form to get certificate.